Alright, now we're getting to value types for solidity. So in value types, we're gonna start with integer. So you have integer and unsigned integer. So in solidity, you can use uint, which is short for unsigned integer, and you can choose a size from uint 8 to uint 256. Uint 8 starts from 0 to 2 to the power of 8 minus 1, which is 255. Uint 16 start from 0 to 2 to the power 16 minus 1, and so on, so on, all the way to uint 256, which starts from 0 to 2 to the power of 256 minus 1. Right? It's a super big number. What you're gonna do, this is how you're gonna declare variables. You're gonna have uint 8. Of course, you have a visibility identifier. Here's like public u8 equal to 1, uint 256 public u and name. So you start with the type, visibility identifier, then the name of the variables and the assignment, right? So if you don't assign something, it's gonna automatically default to 0 for integer and unsigned integer, and then as you see uint 256 public u256 equal to 456 and so on, right? If you don't add a 256 or add any number into the type declarations, what you're gonna have is you're gonna have it automatically defaulted to uint 256, the biggest one. So if you do uint public u, just a name variable, this one is automatically it's gonna be uint 256. Then you go to int, which is short for integer, and you can choose a size from int 8 to int 256. Unsigned integer, which is a positive number, right? Unsigned, right? There's no sign. And integer will also covers the negative and the positive one. So you have int 8 start from negative 2 to power of 7 to 2 to power of 7 minus 1, and so on these ones over here. And so for example, you have int 8, we declare a variable called i8, and then it's type int 8 and it's public, and you assign values called -1 similarly for this one. And when very similar to unsigned integer, if you don't add a number after the integer the type declarations, it's automatically will default to integer 256. All right. You have all these operators you can use with integer and unsigned integer, comparison, bit operations, shifts, additions, subtractions, multiplication, and for you to define the min and the max of the variable, what you can also do is just do for type integer variable x, what you can use is you can do this syntax type x times type x dot min or type x dot max to access the smallest and biggest value respectively for that type. For example, if you want to assign, for example here, right, you can do min integer variable is public, and also it's a type int, which is going to be defaulted in 256. All you can do is a type int dot min. You get a minimum number, the smallest number possible for this assign into this variable. Similarly for the max integer, and similarly for unsigned, right? So all these things will work like that. Next part, we're get into bool. Bool means boolean and has two possible values, which are true and false. So you have bool public true var equal to true, and you can declare a variable called false var public visibility, and the type is bool, and it's going to be assigned as a false. So basically, this is the way you declare a boolean variable. You have all these operators you can use. You have this sign for logical negations. The 2n sign is logical conjunction, or n from understanding from human perspective. You have two vertical lines as logical disjunctions, or the or. Two equal signs will be equality, and a bang and an equal sign will be inequality. So the operators, two vertical signs, the operator or and n apply the common short-circuiting rules, which means that in the expressions, for example, you evaluating two conditions, right? Fx or gy. So if fx evaluates to true, gy will not be evaluated, even if it may have any side effects, maybe wrong, maybe it will change the outcomes later on. It doesn't matter. It just, if it's something evaluates to true beginning, it just short circuit right there, right? So we get into the address section. So address is a special data type in Solidity that allows storing 20 bytes inside of the address of an EVM account. So you also have address payable, similar to address, but when you convert an address type into address payable type, you also add more methods into the type itself, right? So we have an example here. Actually, it would be not 2 but 3. But you have 2 more methods, and you have the call, which is the underlying, the low-level call for this one. You have the address public example address, which is this one. You also have an address payable public example payable address. Let's take this code over to Remix, and then you can start taking a look at this. All right. So I have the code set up right here. You have address public example address. And you also have address payable public example payable address, right? Which the way I do is I take this address, I wrap that inside functions called payable, right? And then this will convert this into a payable. Basically, you are assigning this variable to be the payable version of this address. So if you do something like get address balance, no issues, right? On addresses, you can have access to this method called balance. So you can see like how much ether or the native currency is in this address. But then for you, if you want to, for example, if I want to use example address here, it's not gonna be able to compile because send and transfer are only available for objects of type address payable. So if I switch back to this one, it works now, right? So when you convert an address into payable format, you unlock transfer method and also send method. However, as of right now, these two functions are no longer recommended to be used for sending native currency ether. The reason why is because it's poor handling on failure, and also like return errors and so on, especially when you interact with external contracts. So the way that is being recommended at the moment is you use something like this, which is you use call, which is a low-level method that's available for these addresses. What you can do is you can send ether to the wallet by declaring some syntax like this, which is you take the address, you use a method called call, and then you will declare the syntax like this, which is adding the value and how much you want to send it, plus this, right? This is the data part, the code data part that is gonna be attached along the transactions. So then the address that's calling these functions will be sending native currency over to this address over here, and then this method is returning two things. One is a boolean, basically the status. Think about it as like a status on if the transfer has been successful, right? So you can do something like this where you have a require, and if this one is a false, you just you just revert the entire functions. But if it's true, it proceeds, right? You also have options to also add in bytes, some data here, because this potentially some interactions can also return you data. So this can also be, you can start working on some logic for you to kind of manipulate data, to also update the states on some of the functions, some of the variables, and so on. So this call is much more powerful compared to these two methods, which is the reason why these two functions are no longer recommended to be used for sending native currency. You're gonna be using call. Next part is we getting into bytes. In Solidity, the byte data type represents a sequence of bytes. Solidity has two types of bytes. You have fixed size byte arrays, and you have dynamic size byte arrays. The bytes keyword in Solidity represents a dynamic array of bytes. Essentially, it's a shorthand for byte array, right? So you have something like, you can have something like bytes1, which is for a variable a, which is gonna be n is equal to 0xb5, which is gonna be this sequence, a byte. And then you have bytes, like for example, b variable with type bytes1 for could be a side variable or a value of 0x56, which is gonna be this sequence. For a string like abc, it's gonna be this sequence, right? So that's just bytes. It's a low value raw data type in Solidity. So you can also have, in Solidity, you can also have default values for all of your variables. And if you declare variables without value assignment, it will have the default values. Right? So if you do declare a Boolean variable without assigning any value to it, it would just automatically resolve to false initially. Same as unsigned integer is going to resolve to 0. Integer is going to go to 0. Address, the default address for address type is going to be the 0 address, which is 0x00 all the way to the end. For bytes type, the default byte is 0x00. So next part we'll get to is a contract. Contract keyword is used to declare a contract in Solidity. So you can have something like contract, hello world, and curly braces, because Solidity is a curly braces language. So you use curly braces to define the scope of the contract. And something like this, contract, hello world, curly braces, is 100% valid Solidity code. So you can have something just like this. Does absolutely nothing, but you can have something like this, and it will compile. What you can also do in Solidity is inheritance, which means your contract can inherit another contract, and then we also inherit the functions inside also the contracts until you override it with the keyword called supper. You will work on that a little bit later. Type. A user-defined value type allows creating a zero-cost abstraction over an elementary value type. So you can use the keyword type to essentially create an alias for another type, but with stricter type requirements. User-defined value type is defined using the syntax type C is V, where C is the name of the newly introduced type, and V has to be a built-in value type. Right? For example, like uint256, int256 string, those ones. Right? So you can do something like this. You can represent an 18 decimal 256-bit y fixed point type using a user-defined value type. So you can do type unsigned fixed 256 times 18 decimal is uint256. Right? So you can creating an alias for your type. So lastly, functions. So you can use function keyword to declare a function in Solidity, and function is where you host your logics. So you can do something like contract counter. You have like a variable, like a state variable, and then you have a function to call it out, right? You have functions, you use the word functions, then comes the name of the function, right? And then the input. There's no input in this case, so that's why the input is gonna be empty. Public, which is the function visibility visibility modifier. Public means it's a function is gonna be publicly available for everyone to call, all the contracts and everyone to call it. You have the view, that means that this doesn't change the state. Returns, so it will return a uint256 number to you, and inside the logic is gonna be just return the state variables, in this case count. Right?